All right, hello. It's 7.5.3 Properties of Operations, and that starts on page 367. Write that all down. Pause if you need to. All right, the real world link says that Miss Ricardo drives up and down her street to complete different errands. Some of the places on her street are shown below. The number of blocks between the places are also shown. So suppose Miss Ricardo drives from home to the game store and back. Write an expression for each distance. From home to the game store, from the game store to home. Alright, so from home to the game store, it is 2 blocks plus 1 more block, so it's 3 blocks altogether. And then to go back home, it's going to be 3 more blocks. Alright, then it says circle the property that illustrates exercise 1. So saying 2 plus 1 or saying 1 plus 2 is really what they're talking about. What property is that? Is that commutative or associative? Remember that commutative is change order, C-O, change order commutative. And so changing the order is commutative property. Associative property would be changing the groupings. So number 3, on Monday, Miss Ricardo drives from home, stops at the library, then drives to the football field. On Tuesday, she drives from home, stops at the game store, and then drives to the football field. Write an expression for each distance. Oh, sorry, I was supposed to write an expression. Durr. Okay, let me redo this. So this was supposed to be 2 plus 1 and then 1 plus 2. All right, I'm back. So on Monday, Miss Ricardo drives from home, stops at the library. So let's figure this out. She goes from home, she stops at the library, that's 2. And then she drives to the football field. So then she goes through the 1 plus 3 to get to the football field. So it's going to be an expression of 2 plus, and then in parentheses, 1 plus 3. And then it says that on Tuesday, so let me get rid of this. On Tuesday, she drives from home, stops at the game store, so she goes 2 plus 1, and then goes on to the football field, which is plus 3. So now we've got in parentheses 2 plus 1, because that was grouped together because that's how we figured out how to get to the game store. And then plus 3 more, because that's how we get to the football field. So the next question is saying to circle the property that illustrates the exercise 3, 2 plus, and then 1 plus 3, and then 2 plus 1 in parentheses plus 3, and that's going to be associative property because I'm just changing what's inside the parentheses and deciding which one I'm grouping together. And either way, it's going to come to the same answer. Alright, so commutative property states that the order in which the numbers are added or multiplied does not change the sum or product. So I need you to copy these down. This is kind of our vocab. You've seen it before. This is not the first time. You should have seen it in elementary school. Commutative property states that the order does not change the sum or product. Okay? This only works for addition and multiplication. It does not work for division and subtraction. Not division and subtraction. Associative property states that the way in which numbers are grouped when added does not change the sum or product. So again, we're talking about adding and multiplying, not dividing and subtracting. So associative property is that it says that the way in which numbers are grouped when they are added or multiplied does not change the sum or product. Alright, if you need more time to copy this down, then you can take more time. They have their little examples if you'd like to show your examples. There's the situation from the first page. Feel free to copy those down. So it says a property is a statement that is true for any number. The following properties are also true for any numbers. Additive identity. So we're going to write all of these down. I don't really care if you talk about the property. Let's talk, we want these, is what we want. So additive identity is that when 0 is added to any number, the sum is the number. So you add 0 to anything and it stays the same. You've got A plus 0, it's A. You've got 1 billion plus 0, it's 1 billion. Okay? Then we've got multiplicative identity. When any number is multiplied by 1, the product is the number. So with multiplication identity, that's what I'm going to say, so let it go. Anything times 1 is itself. So A times 1 is A. 1 times A is A. 1 billion times 1 is 1 billion. Okay. Multiplication property of 0. When any number is multiplied by 0, the product is always 0. So we know that anything times 0 is 0. So example number 1, again, these are not new at all. We're just putting variables in the mix now. Name the property shown by the statement 2 times 5 times n and 2 times 5 times n. The order of the numbers and variable did not change, but their grouping did. So what I'd always recommend is look at the order. Did we stay the same? 2, 5n, 2, 5n. Order stayed the same, not commutative property. So we're now going to look at it and think, okay, well, did the grouping change? And the grouping did change, so that's associative property. So if you'd like to write down this example is associative property. So you're going to do A and B. You're just letting us know what property is being used here. And you can refer back to, and it should be in your list already, both commutative property, associative property, additive property, multiplication identity, multiplication property of 0. So go ahead and check those out for A and B. Pause the video now. Alright, so for A we've got commutative property, because if you notice, we've got 42 plus x plus y, 42y then x. So if you just look at it, you see that the order is not the same. Because it's all addition, we can do that, but we're going to call it, because we can do that because of commutative property of addition, if you want to add that. B is plus 0. Of course, adding 0 doesn't change anything. It just makes it the same. So 3x plus 0 is still just 3x. So that's additive identity. Because if we add 0, it stays the answer stays the same. You may wonder if any of the properties apply to subtraction or division. If you can find a counter example, an example that shows that a conjecture is false, the property does not apply. So here's an example. If you have 15 divided by 3, is that the same as 3 divided by 15? The answer is no, because 15 divided by 3 is 5, but 3 divided by 15 is 1/5. So division is not commutative. So now here's a got it for you. The difference of two different whole numbers is always less than both of the two numbers. So let's say the difference of two different whole numbers, so I'm just going to say A minus B is always less than both of the two, is always less than both of the two numbers. Is always less than both of the two numbers. So that's saying that A minus B is always going to be less than A, and that A minus B is always going to be less than B. So let's give A and B some identities here and say I'm going to say that this is 5 and this is 2. So let's try it out. 5 minus 2 is less than 5. 3 is less than 5. Okay, well that works out. And then let's say the next one is, oh, I'm sorry, we already came up with a raise. 5 minus 2 is less than 2. 5 minus 2 is 3. Is 3 less than 2? No, that didn't work. So actually we find out that the difference of two different whole numbers is not always less than both of the two numbers. So in this case, the difference of those two numbers was greater than the original second number. Okay, so that's not always going to be the case. That's interesting. I like that. I've never seen that kind of thing before. The comparison was interesting. I'm a nerd. All right, example number 3. Elena wants to buy a sweater that costs $38, sunglasses that cost $14, a pair of jeans that cost $22, and a t-shirt that costs $16. Use mental math to find the total cost before tax. So writing the expression for total costs, you can rearrange the numbers using the properties of math and look for the sums that are multiples of 10. So for instance, I know that 14 and 16 will make 30, and I know that 38 and 22 will make 60, and so then I can add the two together to make 90. So it's just changing the order. Commutative property gives me that right, and then I can use my grouping skills of associative property to put together my two sets of numbers that make nice round numbers. And I do that all the time when I'm adding. I just change up the order to make sure it's easy math. All right. So you're going to do this one. Lance made 4 phone calls from his cell phone today. The calls lasted 4.7, 9.4, 2.3, and 10.6 minutes. Use mental math to find the total amount of time he spent on the phone. Now, although you're using mental math, I'd like for you to write down what groupings you did and what order you chose to put it in. Did you leave it in this order? Did you choose to group some things to make your math a little bit easier? Pause the video now and let's do this. Alright, so my final answer was 27 minutes, and the way that I worked that out was that I chose to put together my 4.7 and 2.3 because I knew my 0.7.3 would make a whole. Then I put together my 9.4 and my 10.6 because I knew that my 4 and my 6 would together make one whole, and therefore giving me some nice round numbers to add together, and getting 7 plus 20 is 27. So 27 minutes is the total amount of time spent on the phone. Example number 4 says that 7 plus g in parentheses plus 5. To simplify that, we can combine like terms. Remember combining like terms? Let's write that down. Combine like terms. Like terms is a very important phrase to get to know because you're going to be using it a lot throughout your middle school and high school math careers. So with 7 plus g, I can't put that together. I don't know how to combine those two. I don't know what g is. But I do know that I can add 7 and 5 together. So how about I change up my order? And I'm going to say 7 plus 5 plus g. And I'm going to group together my 7 and 5 because I want to combine those two to make it 12 plus g or g plus 12. That way I've simplified it as best I can. I can't go any better than that. I'm just simplifying it. Either one of these answers would be fine. I can't go any further because I don't know what g is. For this one, I like that they showed this. M times 11 times m, my like terms are my m's. So I'm going to change my order, and instead of m times 11 times m, I'm going to say, okay, how about m times 11? And I can put together my two m's. And now when you multiply the same number twice, that's the same as squaring it. Not saying 2 times m. That wouldn't be right. M times m equals m squared. Okay, m plus m makes 2m's. But we're talking about multiplication. And then we're going to multiply that times 11, which can be written as 11 times m squared, because remember we want to put it in order with our coefficient. So 11 times m squared is the same as m squared times 11. Excellent job. All right, so, and I'm talking to myself, obviously, because I'm pretty great. So let's do E together. Well, actually, know what? You do it on your own. Do E on your own, and you'll come back and we'll go over that. Pause the video. All right. No. All right, sorry, Mr. Bocelli's distracting. So 4 times 3 times C times 2 is what this really says. And so if I want to combine my like terms, I know that I can put together 4 times 3 times 2 and then multiply that times C. So I'm going to put together these to simplify. Remember, I'm not solving, I'm just simplifying. So 4 times 3 is 12, 12 times 2 is 24, and it's going to be 24 times C. And this can only work because it's all multiplication, so 24C should be your final answer. I wonder how many of you got that correct, but I hope you understand the method now, that this is all multiplication and I can combine my 4 times 3 times 2 to simplify it. That ends the lesson, so hope you guys enjoyed, and I will see you in school. Bye.
you like to?